Hello, I'd like to go over some constant velocity motion basics in this video. So we'd first like to start with some vocabulary. So the first term we come across is position. Position is the location of an object relative to a coordinate system, and it's just measured in some sort of length units. Usually we use meters. The next one is thinking about displacement. Displacement is the change in position of an object between a starting time and an ending time. I'd like to show a little piece from the kinetic books looking at the idea of displacement. So here we show a little object that's moving along, and the displacement takes into account both the final position that something is relative to where it started. So the displacement for this little object is that it is 6 meters in the positive direction. And we don't pay any attention to how far it's moved in between. We just look at the beginning location and the final location, and the change in location position between those two is what we call displacement. And when you're thinking about displacement, you always want to think about it being the final position minus the initial position. And the final vocabulary I want to look at is distance. So distance is the total length that something travels, not just ignoring the direction. So for instance, with these arrows over here, let's suppose we have an object that first moves 6 meters to the right, then turns around and moves 2 meters to the left, and then turns around again and moves 7 meters back to the right. The distance that object is covered is just adding up each of those numbers, ignoring the sign. So 6 plus 2 plus 7, which equals 15 meters. You can think about distance as being the amount of length. If you were actually walking this motion, how far would you have walked? The displacement, however, is plus 11 meters, which is equal to the 6 minus 2 plus 7, taking into account that direction. So if the object starts here at the beginning of this arrow, it ends at this arrow, the end of this arrow over here, which is plus 11 meters away. So the difference between displacement and distance is an important one. Here we show a position graph. So a position graph gives you a visual of what their location is or the position of an object at various points in time. So here we see an object that started out at 8 meters along the position axis. And if you can imagine this number line down here, thinking about this being our coordinate system, maybe it's a meter stick. And we have an object X starting out over here at 8 units away in the positive direction. That's what this piece up here is showing us, this dot up here. And then this object starts moving to the left, so the position graph is going down. And it shows that after 3 seconds, it's at a position of 4 meters. So the object moves to the left here until it gets to 4 meters. Then this horizontal line segment means that it hangs out there for a while and just is at rest. Then it keeps moving in that same direction to the left until it gets to a position further down here, and at this point is when it crosses the origin. So it's moving back in this direction, it crosses the 0 point, and then it stops here after 12 seconds. Well, it doesn't stop, it turns around and moves back in the forward direction until it gets to the end of 15 seconds. So the distance this object traveled, we can figure out by adding up each of these pieces for how far the object traveled. So it traveled 4 meters in the first segment, and then 0 meters in this segment, 6 meters in this next segment, and the last segment it traveled 8 meters in the positive direction, which if we add up all those numbers together, we get 18 meters. The displacement is given by the final position here, which is 6 meters, minus the initial position here, which is 8 meters. The displacement comes out to be negative 2 meters, meaning that the object started or ended at a position to the left where it started from. Okay, another set of vocabulary here involves how fast something is moving. So we have 2 different quantities, speed and velocity. So speed is given by distance over time, and it's always a positive number. Velocity is given by displacement over time, and it can be either positive or negative. If something has a positive velocity, it means it's moving in a positive direction. Usually we mean that's to the right, to the east, or up. And if something has a negative velocity, it means it's moving in the negative direction. And that's either to the left, to the west, or down. So positive and negative velocity just tell us about the direction that something is moving. From the position graph, we can find out these things. So looking at a position graph, if we want to find the speed, we look at the distance over time. We calculated the distance earlier by adding up all these different line segments for how far the object had gone. So we had 18 meters over the total amount of time was 15 seconds. So that gives us a speed of 1.2 meters per second, which is different from the velocity. The velocity is the displacement over time. We found the displacement of this to be that negative 2 meters from where it started to where it finished over the same amount of time, 15 seconds. So the velocity is negative 0.13 meters per second. And the velocity is negative because overall the object is moving in the negative direction. Now I would like to look at how to make a velocity graph given a position versus time graph. And the way to do that is to look and find the slope of each of these different line segments. And that number we get for the slope is the value for the velocity for the object at during different time intervals. So this is segment 1, and the green lines I've shown here to show us how to find the slope with the rise over run. You need to be very careful with direction, so this has a negative slope, and the rise over run is negative 4 meters over 3 seconds. Gives us negative 1.3 meters per second for this segment. This second segment here has a velocity of 0 because the object's not moving. In segment number 3, the object is moving 6 meters in 6 seconds, so it's a velocity of negative 1 meter per second. And the final slope is a positive value of 2.67 meters per second. We take those values and plot them on our velocity graph. So the velocity graph, each one of those segments from the position graph is a horizontal line in the velocity graph because the object is moving at constant velocity. So it's a constant velocity here of the negative 1.3. Here it's a constant velocity of 0. Here it's another constant velocity, just a different value. And here the last segment was a constant positive velocity. So here I have a practice problem for you to do. And what I'd like you to do is pause the video and look at the graph, take out a sheet of paper and draw the velocity versus time graph on your own, and then determine the answers to these following questions. And when you figure out those answers, you can come back to the video and continue to play it, and you'll see the answers. So I'd like you to pause the video here. So hopefully you come back and you've determined the answers to, you've made your own velocity graph for that position versus time graph, which should look something like this. Its velocities are different values. It's positive 1, negative 2 point something, 0, and this last one is a little bit over 3. And here are the answers to the questions for the distance covered, the total displacement, and the velocity. I hope this helped figure out, understand how to understand some basic constant velocity motion concepts.